All right. So I'm Amit. I'm today going to talk about Crystal. I hope some of you have heard about it. But if you have not, you have come to the right place, and I'll tell you about it. So let's get started. Okay. So first of all, who's the target audience for this talk? This talk is for the people who have experience working with Ruby, and they've heard of Crystal language, and they haven't had a chance to play with it yet. I won't go too deep into it, but still, like, the talk is kind of long. I thought it was going to be a lightning talk, but I think it's going to be at least 15-20 minutes, I think. So we'll see how it goes. I'll try to rush through it. I'm kind of nervous, and I tend to rush through things when I'm nervous. So we'll see how that goes. All right. Okay, so what are we going to cover? We are going to cover the things that are similar between these two languages, Ruby and Crystal. Also, what does the tooling look like between these languages? And so if you were to switch from working from Ruby into Crystal, what kind of tools that you'll get, and what are the things that you'll use? Also, we'll also look at the things that are completely different between them. So yeah, so first thing first, Crystal is not Ruby. So Crystal is not statically typed Ruby. Syntax is similar, but they are fundamentally different languages. So if you thought you could do something like this, where you went into your Rails project and changed all your Ruby files to Crystal files, and you could do that by running this command in your bash. I got this from Stack Overflow. I think it works. So you did that, and your expectation is something like this. Your result is actually going to be something like this. So that's not going to fly. So that didn't go as well as we thought it'll go. So let's take a step back and let's get to know Crystal a little bit, so that we can do what we came out to do, which was write really fast programs which are statically sound. Okay. So what is Crystal? They build themselves as a language which is almost as slick as Ruby and as fast as C. And from like, if you have worked with Ruby long enough, you know, like, performance is one of the things that you'll run into more often than not. A lot of the times it's the dev who's making that mistake, but sometimes it's just the language itself is just not suited for certain kind of things. So that's where Crystal comes in. So the way Crystal makes it itself really fast is because it's built on LLVM backend, and it gets compiled into a really efficient native code. And because of that, it remains quite fast. And it does that at the cost of not being as dynamic as Ruby. So you don't have dynamic dispatch of methods or things like that that inherently make Ruby slow, because you have to do all of those things that Crystal doesn't even care about. And it does sort of similar things. So like meta programming and all of those things which we really love about Ruby, you can still do that, but it's not like as dynamic as you think they are in Ruby. And we'll cover a little bit of it today. Okay. So I've talked a lot about like Crystal is statically typed language, like, but what does that give us? So let's look at this example. So this is a simple method. It's called stream. It takes an argument X and it upcases it, right? And here we are doing pretty print, PP is pretty print, and we are giving the argument hello to it. So this looks just like Ruby, whereas it's not actually Ruby. This is a Crystal because the name of the file is screen.cr. So you run this method, and how do you run a method, or how do you run a file in Crystal? You type the command crystal run screen, and it's going to do two things. Since Crystal is a compiled language, it's going to compile the language. It's going to compile the file for you, and then it's going to run that file for you. So it runs that, and you get hello back, and where all the characters have been upcased. So that was pretty simple. Now we try something else. Let's say we run it like this, where instead of giving it a string, we gave it a number. So now if similar code we had seen in Ruby. And if we didn't have tests for it, this thing would break. This thing would break when you actually start using it. Whereas in Crystal, you'll get the error as soon as you start compiling it. And that's the first thing that you'll do as soon as you've written something that you'll compile it. So that's the biggest difference between those two. Also, Crystal doesn't make you write the type definitions upfront. So it interprets most of them by itself. I still tend to write type annotations myself so that it becomes a documentation for myself. But you don't have to. Like, your code could still just be having just X in here, and it knows because of the usage that since I'm calling upcase method on it, it's a string. So yeah, and the syntax is very similar to Ruby, and we'll see how similar they are. So here we have a Ruby class. So this is some just plain old Ruby code. I'll run through it really fast to tell you what it is doing, and then we'll see the equivalent Crystal version. They are very similar. So here we have a simple person class. We have two attributes, age and name. The age has a getter and a setter. We did that by having an getter accessor over here. And then we have a name. A name is just a reader, so you can't write that property unless you initialize it. Then you have an initialize method that takes an argument name, and we set that to an instance variable called name. And then we set the age attribute to a default value 0. Then we have a simple greet method, which basically prints out your name and age. How do we use it? We create a new instance of a person. We give it a name, which is John. So now we have P. If you were to call greet at this point, it'll print out John, and age has been defaulted to 0 over here. So we get, hello John, your age is 0. If we set the value of age as 24, which we could do because we had set a setter over here, we can now print out greet like this. So pretty simple stuff. Now, similar code, same code, but in Crystal. Now, the first difference is right here. Instead of using an getter accessor, you'll use property, and property does the same thing. It's setting up a getter and a setter for you. So now the age has a getter and a setter. Whereas if you're doing, if you only want the getter, you'll write getter method. You'll give it an argument. The argument would be the name of the variable or the attribute, and then you give it a type, which is string in our case. Now the next thing, notice over here, instead of giving an argument like this, instead of giving it a named argument over here, we could just do the argument passing in the initialization in a single swoop. And so that's like slightly more handy to do. So when you'll pass in the name, it will get initialized to name automatically. So you don't have to do this step. Then you have age, we are defaulting it to 0, and then the rest follows the same, and the code works exactly the same. So they are very, very similar, but they're still slightly different, which is why our original example failed, where we just bulk renamed all of our file extensions from Ruby to CR. So apart from this, there are some other necessities in Crystal. A couple of them I would like to mention. One is abstract classes, and another one is interfaces. I don't know about you guys, but like a lot of times there are certain things where I have a bunch of classes or bunch of classes that behave almost exactly the same, and they have to have the same methods and same interface essentially. And in Ruby, when I'm trying to enforce that, the way I would do it is I would either make a class, it'll have a bunch of methods. All of those methods, their definitions would just simply raise, and I would expect somebody to inherit from those classes and then define their own method. That's how I enforce some sort of standard interface of on multiple classes that have the shared same behavior. Whereas in Crystal, you actually get like first-class support for interfaces as well as abstract classes. So you could do all of that, and compiler would actually enforce all of those things for you. So you're not like just making language do what you actually want it to do, whereas the language actually has like a high level support for it. Okay, so that's the syntax. Other thing, nils, things that most of the Ruby programmers love a lot. Nils. We've seen that in our program a lot, which is we were trying to call a method on an object, and that object wasn't there. It was replaced by nil because we didn't get the data that we were expecting. In Crystal, we don't have all the types, like all the top level types, like string, integers. They're all non-nillable. So how do we deal with nils in Crystal? So in Crystal, a nillable variable is actually a union between a given type and a nil. And as a consequence of that, what happens is the compiler would check for nil references at the compile time, which means you would have to make the determination in your code upfront that once I encounter the nil, what should I do? And so you won't see nils in the code that has already been pushed out, or like if you have specs, then maybe your specs would catch it. But usually, if your program is compiling, you would expect it to most likely work. So let's just look at a small example where it comes in handy. So we have the same method that we had earlier, screen. It does exactly the same thing as before. But now we are not calling screen directly. What we are doing is we have a method called randomizer. And randomizer calls screens randomly. Sometimes it calls it with hello, and sometimes it calls it with nil. And we are pretty printing the output of randomizer. So when we run this program, the compiler would scream at us and it'll tell us that in one of the cases, you are going to pass nil into it. And I know that you can't do that because I don't have a method upcase on nil. So you won't run into an issue of ever passing nil accidentally somewhere where it's not expected. So you have to address that as you're writing your code instead of when you're using your code. All right, so we are done with the syntax part. We're done with the nil checks. Let's look at the tooling bit now. The things that are similar in Ruby and Crystal, package management. So in Ruby, we know we can use gem files to get external libraries. All we have to do is just have a gem file, define your gems in it, and you just use bundler to bundle your gems, and that does the trick. In Crystal, you have shards. So they have taken the Crystal bit of the language like to very hard, and so everything is like in the same domain. So Crystal has shards, so they have shards. So so this is how you define how your dependencies are going to be. The tool itself is called shards, and if you have to install these dependencies, you'll say shards install the same way you would say bundle install, and it will install the dependencies for you. And similar to Ruby, how you can get gems from the standard library, or you want to get it from GitHub, you can do all of that in Crystal as well. Okay, so that's done. Testing. Yeah, so testing is quite important. And in Ruby, usually you would use something like RSpec or Minitest. And that's how your typical test looks like. Whereas in Crystal, there is a built-in tool called spec, and it looks pretty much the same. And there is one big difference, though, that this spec tool, the API is very limited. So you don't get niceties like let or things that let you write specs like in a more concise way. Like, so the specs are like quite verbose because the setup and the tear down, you have to do that manually. So you will end up defining your own methods that you call before running the actual test. Whereas in RSpec, you could have before and after callbacks and all of that. And that will do those kind of things for you. But apart from that, like it works pretty much the same. All right, yeah, REPL. Yeah, so this is a bit important one. So Now, in Ruby, I use IRB and pry a lot as I'm like playing around with the API, or like if I'm just trying out certain things to try out my code. And to do the similar thing, you have something called ICR in Crystal, and it's a REPL. But one thing that makes ICR slightly different is that Crystal is a compiled language. So even the code that you're typing in the REPL, it has to be compiled before it could actually show you the result. So when it does that, it sometimes loses the state of your program. So like sometimes if you had a variable a is equal to 1, you compiled it and you got the result of it. Next time you're using it within the same ICR session, it might get jumbled up. So instead of using a REPL, what I usually end up using is just pretty printing and having a long as string, and I'll call this before I wanna see the result if I got there or not, or if the function is doing the thing that I'm expecting it to do or not. All right. Oh yeah, web frameworks. So in Ruby we have Rails. In Crystal we have Lucky and Amber. They are quite high-level frameworks. They give you routing, they give you session support, they have ORMs as well. So they also give you templating. So you could pretty much do almost all the things. They're not as nice as Rails because these frameworks are like still not mature enough, but they do the job. Like you'll have to like read the documentation yourself sometimes to make the sense of it, but they mostly work. If you don't want something as full-featured as Rails, you can also go with Camel, and that's very similar to how Sinatra is. So it's very lightweight. All you do is just define a bunch of endpoints, and you do your thing. All right. Now the best bits. So Crystal has a lot of good things going for it, apart from the speed of your programs. So one of them is the standard library. The standard library has really good examples, and the documentation is quite decent. And that's useful because like since there are not too many examples out there, and like not too much content out there for things, so you need to have good standard documentation so that you can read through it and make sense of things yourself. All right. Yep. So one big thing that's a big selling point in Crystal is concurrency. So it has a first-class support for concurrency in Crystal, and to enable concurrency, Crystal is based on CSP paradigm, where Crystal uses green threads called fibers to achieve concurrency. And fibers communicate with each other using channels, the same way they do in Golang or Clojure, and they don't use shared memory or locks to do that. So I'll just walk through like a very simple example around concurrency, around what this guy is doing. So what's happening over here is we've defined a channel. A channel is that communication medium where threads, these green threads called fibers, they talk to each other. So we have defined a channel. We've said that this channel is type of string. So anything we communicate over this channel is going to be of string type. Now we run the loop 5 times, and then we spawn. So this spawn is the asynchronous bit, which is, so we are spawning off these threads. So we have spawned these 5 threads, and each time we have spawned this thread, they go and run asynchronously, and when they start executing, they send the message hi there onto that channel. Now within this loop itself, we are also doing a channel.receive. Now this channel.receive is a blocking call, and this is going to wait for when somebody sends a message on that channel. So we have like 5 threads that got spawned off. Each of them sent 5 messages, hi there, hi there, hi there, and they all get find back in. and they all get printed over here, channel.receive. If you were to do similar thing in Ruby, you would have done something like this, where you spawned off 5 threads. They all do a print, and then you join them back in to get the output. Okay, what's the last thing? JSON. Yep. Since I've worked with APIs, JSON APIs a lot, the JSON serialization capabilities of Crystal, those are quite nice. And that's the last thing that I'm going to cover, and then I should be done. So we'll just briefly go over what this is trying to do, and we'll see an example of how this gets used. So we have included a library JSON at the top. We have defined 2 classes, location and house. They have, so let's look at the house first. So in house, we have 2 properties, address and location. Address is of type string, location is type of location, and it has a question mark over here. Question mark denotes that this thing can be nillable. So it's a union between location and a nil type. Now, what is the location? Location is over here. It has 2 properties, latitude and longitude. Latitude, and both of them are float 64s. We also have these notations, annotations over here. These are coming because of this JSON serializable. And what that is giving you is ability to get the JSON data. So you have if you have a JSON object, you could just parse it to a statically typed location crystal object without anything, without any manual intervention, essentially. And also, this gives you ability to have custom keys as you're giving the JSON out, or as you're receiving it. So how does this get used? So let's say we wanted to create an instance of house, and we got this JSON in the input from an external API. All you have to do is call from JSON on it, and it will parse this whole thing, and it will serialize it as a house object, and you can call all the attributes on it. So we can call house.address, house.location. You could do it on an arrays as well. So you can get an array of all of these objects as plain JSON, and as soon as you call from JSON on it, you get an array of houses that you can play around with. So you don't have to manually construct a house object by reading like each of those fields. It will do all of that automatically for you, and it will make sure that all the external input that you're getting like conforms to the spec that you have set up for yourself through your type definitions. Oh, I completely forgot about this guy. Macros. So macros are for metaprogramming. Okay, so what's happening over here? So in Ruby, you can write code that writes your code, right? And if you were to do the same thing in Crystal, this is how you would do it. So here we are defining a macro. That macro is called define method, and it takes a name, it takes a content, and what it's doing, it's just writing some code essentially. And as soon as you write these 2 things, what that has essentially done is it has written these 3 methods for you, so you can call them. And all of this happens at the compilation time, so you don't pay the penalty of dynamic dispatching. So it's essentially you are writing your code as a template essentially, and so that's how Crystal supports metaprogramming. That's it. It's done. Any questions? This was the longest presentation.
That was great. Well done. Didn't seem nervous, even you said you were. You did really. It's great. Oh, Mike's got a question. I'll stop making noises. Go, Mike.
Also, yeah, I was wondering like what the performance is actually like compared to like maybe Ruby and Elixir and like other frameworks. If you have.
So it's close to C.
Awesome.
Yeah. So yeah, I didn't go over like benchmarks and stuff because like you can find them anywhere on the internet. Like I wanted to go over like more about like how does the language feel like when you're using it on a day-to-day basis. Um, but yeah, like it's quite fast. So we've recently done like a couple of projects. Both of them are getting used in production quite heavily, and it works really well. And the best part is, like, if your code compiles, it'll most likely work. Like, whereas in Ruby, like I love the language, but like unless I have a good test suite backing it up, like I still don't feel confident until like I know like I've covered all the edge cases. Yeah. Also, like with Ruby 3, I think performance like is becoming better. Also, I think we're getting a better concurrency story as well. So there are good things coming in Ruby pipeline as well. But just like one other thing in your, because it's like not so different than Ruby, you could use it for something where you did need like extra perf.
Awesome, thank you.
Yep.
I'm going to get in before anyone else does. I felt like the stars aligned that we had a talk about SemGrep that's useful at going through and like figuring out like changes. You could maybe turn your Ruby code into Crystal code using SemGrep, and it would be a beautiful synergy of technologies. Anyway, I just had to get that up before anyone else got the joke. Cool. That was great. That was going to be my question, was to ask if you were using this in production, and you are. That's it's great. I often wanted to try, but I've never gotten around to do it. So that was really, really useful.
What is your production app? I've had a bit of a play with Lucky recently, but I don't know, maybe my computer's old or something. But every change I make, it then takes 4 seconds to recompile before I can see that show up in the browser.
Oh, it does. You're right. So we have written a bunch of components. So we've been working on this app. It's they call themselves Place OS, and the use case is like, I don't know, like if you've gone into like big buildings, you see these kiosk systems, right? So they are driving like these devices which are so they show up as these kiosk systems. So it's running a web framework to show like that kind of interface, and then it also runs like bunch of driver integration small modules which run like all independently, and they communicate with like different parts of the building. So you might have like a controller for like automatic windows or automatic rooms, and like security for those kind of things. So we have been working on so the bit that we worked on was a calendaring portion of it. So so it would give you ability to interact with what is it, the Google and Microsoft's API to manage calendar of people and the calendar of rooms as you're booking them. So that's one thing. The other one that we are just started working on is like controlling lights and like turning them on and off automatically, like when the room is in use or when it's not in use, that kind of a thing. But you are right, like the compilation, we weren't even using Lucky. We were using this framework called Router, which is like very, very minimal. It's almost like close to the native HTTP server that you get from the language, and like just like small bits added to it. And it didn't have reloading. Like, so anytime I would make a change, I would have to like stop the server, rerun the server. So at least like within 4 seconds, your server runs. Like mine, like I actually have to manually restart the thing. But yeah, it's like a new language. They haven't even hit 1.0. So I think they'll get better. But I completely agree with you. Like I think they still have like certain things to figure out. But once the thing is compiled, then it's fast.
Oh yeah.
Yeah.
Cool. Thanks.